Assalamualaikum and a very good day to Sisawawi and everyone. We are from group CS110-2A. Today our team will present our csc186 object-oriented programming final project titled Clinic Patient Appointment and Billing System. This system is a Java console application designed to streamline healthcare administration by managing patient records, doctor availability, appointments and billing diagnosis. Our project truly applies core OOP concepts including classes and objects, inheritance, aggregation, composition and polymorphism. This presentation will strictly follow the criteria order specified in the assessment rubric. Our organizational structure consists of 4 specialized roles to ensure high project quality. First, Waskoni bin Rumaizi is our project manager and team leader, responsible for managing timelines and overseeing task delegation. Next, Muhammad Lufi Hanif bin Muhammad Ilmi acts as our project programmer who actively wrote and implemented the Java source code based on our system design. I, Muhammad Amin Solihin bin Shamsul, serve as the project tester and quality assurance, executing test cases to make sure the program functions as exactly as expected. Finally, Muhammad Shafiq Salihin bin Jose is our project innovation strategist, looking for innovative ways to enhance the system features. Right now, many clinics manage their daily operations manually or use old tools. This manual process causes data redundancy, human errors in medical history logging, and overlapping appointment schedules. It is also very slow for staff to manage doctor availability and patient queues by hand. Our proposed Java system solves this problem using OOP concepts. Patient, doctor, and appointment data are read automatically from input text files and stored into memory structures. We use an abstract appointment superclass with 2 subclasses, general appointment and specialist appointment. Staff can also analyze clinic revenue automatically. For example, a general consultation calculates the fee by adding the base rate, room usage fee, and a specific surcharge. A specialist consultation multiplies the base rate by a specialization modifier. The system repeats this calculation across all objects to evaluate the clinic's earnings. Our clinic system accomplishes 3 key objectives. First, to prioritize patient queues by using a sorting algorithm to make sure critical cases are handled first, even if walk-ins. Second, to locate patient records easily by using a search algorithm to find information by ID or name. And for the third, to apply counting, minimum or maximum and averaging algorithms to generate a comprehensive revenue report based on appointment types.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq Salihin bin Jose and I am the project innovation strategist for this group. Now, I will explain the scope of our system. So basically in our system, we have 6 main class, which is appointment, general appointment, specialist appointment, patient, medical record, and doctor. So basically in this system, we have only one main user, which is the clinic administrator. The administrator can perform 8 main tasks such as regarding patients, booking appointments, and generating financial report. Next, let's look at our UML class diagram. So first thing first, the main class is appointment. It holds basic detail like appointment ID, date, time, and test rate. So after that, we have 2 subclass under it, which is general appointment and specialist appointment. This show the inheritance relationship. Both subclass use a method called calculate fee to calculate different pricing logic. So next, appointment has an aggregation link with patient and doctor. This means if an appointment is cancelled or delayed, the patient and doctor data will stay safe in the system. Lastly, we can see the black diamond on patient. So basically that means it has a composition relationship with medical record. This means medical record cannot exist without patient. So basically if we delete a patient, all of their medical history is deleted automatically. Now let's see our use case diagram. Our only actor is the clinic administrator. So basically the administrator can do key operation like register patient, manage patient record, schedule appointment, and generate a revenue report. We also include a special relationship here, which is update patient detail has the extend line to manage patient record. This means extend line have here because editing only happen when needed. After that, schedule appointment included sort queue by severity and verify doctor availability to prevent double booking. Finally, when we generate revenue report, it will automatically include 3 tasks, which is calculating average revenue, counting the total consultation, and finding the highest revenue type. So basically, this complete the scope design of our system.
The system reads 4 input files. The first one is the appointment files. Each appointment record has 8 or 9 fields depending on the appointment type, which can be discerned by the first character of the appointment IDs. The appointments have 8 or 9 fields because it was designed with inheritance in mind. Specialist appointments only have 8 fields, with the extra field being specialist area, for instance here radiology, while general appointments have 2 extra fields, which is room number and consultation type. File 2 and 3 are doctor file and patient file. They are linked to the appointments in appointment file by doctor ID and patient ID. For patients, the patient ID also links them to medical records, as seen here. Medical records are more than patient number because patients store array of medical records, allowing them to have many medical records that make up their medical history. Moving on to class definitions, here we have the simple class of type, the attributes, and here is the constructor, which is a normal constructor of characters, centers, and down here we have the abstract function, calculate fee, which is a polymorphism, output point to file, and another output to a string. So down to subclasses, we have general appointment, which have the abstract attributes clinical consultation type. The constructor enforces the super constructor before ideating its own attributes. We have getter on the process implements its own logic at a plus 10 ringgit base rate with a surcharge based on consultation type. the write to file function and toString function are overridden and invoke the super function of each function method. On to the next subclass, which is specialist appointment. Same as before, it has an extra attribute specialist area and specialization. The constructor called super with getter, and the process calls its own logic by multiplying the base rate with a modifier based on specialization. The write to file and toString are similar as before. Moving on to the other classes, we have doctor, which has normally getters with output, whatnot. Moving on to patient. Here we can see it stores an array list of medical record objects. It's because of medical records in whole, and we do not know the max size of this list. So we have constructor, getters, output, and whatnot, and the medical record class, which is a pretty standard custom object class. Our main application class is clinic at Java. At the top here, we declare hash maps for doctor and patients. This is because these two object classes have a composition link with appointments and thus need to be linked together to the file loaded. For appointments, we use array lists due to not knowing how many appointments there are going to be, and they are organized into appointment lists or walking queue lists based on their status. These lists are converted into arrays during processing such as sorting or searching. For file loaders, our system reads as a file using buffer index and string tokenizers to pass the file contents. For example, here for patient, it simply constructs a patient object with all the expected information and puts the newly created patient object into patient map. Now, the reason we use patient map is so we can easily link it to the appointments as seen down here. So we can easily insert the patient object into the general appointment construction by simply using the map.get and then using the patient ID. Now, with load appointments, we have unique functionality due to inheritance, where based on the first character of the appointment ID, that in G or S, general appointment or specialist appointment is created. Now, taking advantage of that inheritance, we can call a.getStatus on just once and to check if it's a walking appointment. If it is, we add it to the walking queue list, and if it's not, we add it to the standard appointment list. Polymorphism is best demonstrated in our system through the revenue generation method. So here, we can simply loop over all appointments regardless of type, whether general or specialist, and simply call a single function calculate fee, which will use the appropriate calculate fee method based on the class that based on the specific implementation that we specified in each subclasses. Now, of course, there is a case where we need to count revenue for each type, and in that case, we use the instance of to determine what type of subclass the appointment is, and thus add the fee into the total fee of that appointment type.
Okay, this is our system. When the program starts, both input files are already loaded into the areas of object. The menu offers view appointment, add appointment, edit appointment details, search patient record, update patient details, register new patient, and generate revenue report. First, let's register an object, number 6, enter the name of patient, Asha. Nothing. Okay, enter contact numbers, 01. Okay, 0. Okay, it will give you the patient ID is P046. So after that, if you want to change the details, just go to update patient details above 5. So enter the patient ID, it's P0, as you know, P046. And here is the current detail. If you want, let's say you want to add medical record, enter the years, give complaint, and diagnosis for fever. The treatment, just let's say ICU, and then confirm. Let's view the let's say if you want to add the appointment, choose number 2 and just between number 1 or number 2. Let's say I choose number 2. Enter the patient ID P046 and select the consultation type between general or specialist. Let's say general. Choose the doctor. I prefer Dr. Fatima, and then let's move enter the severity between 1 and 5. 5 is the most urgent. Let's say if you put 5, enter construction type between follow-up or emergency. Let's say it's emergency. Enter clinic number 276. Appointment successfully created. Let's view the appointment. The appointment, all appointment, and it's what here where it's, yeah, here you are. You have Pasha bin now, Dr. Fatima, and the severity general and emergency what it. Here is appointment ID G051. And let's say you want to edit appointment details. Choose number 3, put in the appointment ID. Here we have the current detail. If you want to cancel, just put number 4 to cancel the appointment. And the appointment is already cancelled. Let's say you want to generate revenue report for the whole clinic. That's number 7, and here we are. The higher revenue type specialist is 785. And average appointment fee 51 ringgit and 96 cents. That's it. I think that's it from me. Thank you. Okay, for the slide 7 references. All sources we refer to are acknowledged in our report, including W3 Schools for Java 5 reading, Git4Git for polymorphism, and GitHub for clinic appointment scheduling system baseline. Throughout this project, we use free and legally licensed tools, Draw.io for UML diagram, NetBeans for Java development, and Microsoft Word for the report. And we did not copy any code without citation. This reflects our commitment to academic integrity and the ethical use of digital tools. In conclusion, the clinic and appointment system successfully applies classes and object arrays of object for input inheritance with two subclasses, aggregation, and publication as our bonus feature. Thank you very much for our team.